Hello, everyone, and welcome back to class, Online Conceptual Science. So this week, we are going to grow our scientific skill set by taking a look at chemistry. Chemistry is really cool. When people think of chemistry, they're generally thinking about dynamic reactions, such as taking a piece of metal, sticking it into an acid, and watch it dissolve. Or they tend to think of fireworks, where the powder that is used as part of the charge for the firework actually has a chemical component which allows the changes in color. And that actually allows us to scaffold off of our previous week's lesson. In the previous week's lesson, we learned about physics and how light waves are investigated by physics. But how do we get a light wave? Well, we need to be able to start a chemical reaction. And that is being able to take chemical elements, bond them together, and then take those bonds and introduce each of those bonds to their opposites to get a reaction. And so that's why we need to study conceptually the most basic form of the conceptual and physical model of chemistry by taking a look at different types of bonds and how they work. Things like covalent bonds, ionic bonds, and all that good stuff. And so this lesson is going to be a bit of a multi-layered approach. You're going to learn a couple of different things. And the first thing that you'll learn is the periodic table of elements. This figure is found in many science classrooms, and it's a great figure for communication. This table organizes all of the chemical elements that scientists have discovered. It's sorted, and you can find very useful information, such as the electron configuration, the boiling and freezing points of many of these chemical elements, the density and atomic mass, about how big some of these chemical elements truly are in relation to their nearest neighbors in the table, the symbol and the name, and even the atomic number. These are all great characteristics that help us classify the chemical elements that can be found in the world around us. Chemists study these and want to be able to communicate them. And before we get to a chemical reaction, we need to learn about bonding. And so in this week's lecture, you are going to keep up with your selected readings and reflect upon what you are learning, but then also be introduced into the concept of not only how to read the table, but also how to be able to understand the different types of bonds on a conceptual level. Which types of elements tend to be more favorable to certain kinds of bonds, which ones aren't. And then we take those concepts and mechanically work them and convert them into physical models in the lab this week. We are going to be making what they call ball and stick models, or structural models of different molecules. And being able to understand how these molecules bond together can help inform you for topics later in the course. For an example, here's a ball and stick model of hydrogen. Now, hydrogen, it's very common in our atmosphere. It can bond together, such as this model right here, which would actually be water. H2O, O being oxygen. We have water in the water that obviously we drink it, but also can be found in our atmosphere as it helps drive weather patterns. And speaking of our atmosphere, we also have greenhouse gases, such as such as methane right here. Methane is a really cool molecule that forms, and it actually has been forming through contributions of our biosphere as part of our Earth systems. And scientists, we study methane to help inform us about patterns in not just the weather, but global warming. We actually found a correlation between changes in the ozone layer and methane production. We can also take a look at much more complex molecules. Seen right here, this is alcohol. In fact, it's actually isopropanyl alcohol. So this, on a molecular level, looks like this. And we can get as complex as possible. This is actually my favorite bonded molecule. Can you guess what it is? It's caffeine, the same caffeine that powers my morning Monster energy drink. So that's really what our goal this week is, going to be able to dip your toes into the fundamentals of chemistry. If you have any questions, please reach out. You can reach me by email, you can set up a video chat, or just swing by my office on campus. All right, let's science on.
American sassafras albendum oil is distilled under vacuum to isolate safrole from other phenylpropenes and terpenoids.